So the next group of problems, there's 4 groups of problems in section 5.8. The next group of problems look a lot like the problem that I have on the screen in this little box. 2x squared minus 3x minus 5 equal to 0. What they have in common with the first 21 problems is they're set equal to 0. What they have different is the left side isn't factored. For each one of the problems, my goal is to get the left side factored, or one of the side factored, and the opposite side 0. There were essentially 3 small goals. First goal is to get one side 0. That's done already. Second goal is to get one side factored. This isn't factored, and it's ugly factoring. So in order to get this problem solved, I got to get the left side factored, and typed up how to factor that, so I didn't want to do it by hand. So if I want to factor 2x squared minus 3x minus 5, I multiply the 2 and the negative 5 and get negative 10. I need the plus minus factors of negative 10, smaller number positive. So I did my factors of negative 10, 2 and negative 5, 1 and negative 10. I add the numbers. 2 plus negative 5 is negative 3. 1 plus negative 10 is negative 9. Trying to get this negative 3, so the pair of numbers I'm going to need are negative 5 and positive 2. So the negative 3x in the problem I would write as negative 5x plus 2x. Change the problem to have 3 terms, factor by grouping, so this 2x squared minus 5x plus 2x minus 5, insert parentheses, first parentheses, factor out a 2 and be left with a 2x minus 5, second parentheses, factor out a 1 and be left with a 2x minus 5. That ugliness factors into 2x minus 5 times x plus 1. So I have to use the appropriate factoring technique in this second group of problems to make it so once I start with the right side 0, left side not factored, I use the strategy, whatever strategy I have for factoring from the first 7 sections of the chapter to get the problem factored. And then once I get the problem factored, now I go to my strategy of setting the individual factors equal to 0, and then I do the algebra to get the x isolated. The first factor of 2x minus 5, I first add 5, and then I divide by 2, and that gives me x equal 5 halves. The second factor of x plus 1, I just minus 1, and I write those in my answers. I have 5 halves and negative 1 for my answers, and then I check them to see that I get 0 equal to 0. So that's every problem between 22 and 42. That's what I'm going to have to do. My goal is to get 0 on the right side. It could be on the left side, but usually it's 0 on the right side. I need to get the left side completely factored. After I get that, I set the factors equal to 0 to solve. And then if I'm feeling ambitious, I check. And I check in the original problem, not in the factoring, just in case I factored wrong. So number 22, it's a trinomial. It's a minus plus. That's the second level of my template. I can sight factor. So for this one, minus plus is going to factor into minus and minus. So when I go to factor this, I look at the 6. I write the minus factors of 6, which are minus 1 and minus 6, and minus 2 and minus 3. Now I'm going to add minus 1 and minus 6, and I'm going to add minus 2 and minus 3 to figure out the pairs I need for my factoring. Because the signs are the same, I'm adding the number. The minus 1 and minus 6 adds to minus 7. the minus 2 and minus 3 adds to minus 5. When I go to factor this, I'm going to put a minus 2 and a minus 3 in my parentheses. I didn't do grouping because there wasn't a number in front of the squared term. So to factor this, I'm going to split the x squared evenly into the first positions with a couple of x's, take the numbers that I need and shove them at the end of my parentheses. Now, right side 0, left side's factor, I set this factor is equal to 0 to solve. And at some point, you don't do this step and you just write the answer down, because the algebra you could do in your head. I'll show you how to check this one, but I won't check every one manually. I'll check by looking at my answers. So this is problem 22, and long ways to go. Problem 22, I have 2 and 3 written down for my answers, and I just got 2 and 3, so they're probably right. But how would I check? To check, I can't go to the factoring, because they might check in the factoring but not check in the original problem if I made a factoring mistake. So first I'm going to plug in 2 and see if 2 squared minus 5 times 2 plus 6 equals to 0. Calculator check. If I'm checking, boy, it's so much quicker to calculator check. That one checks because when I plug it in, I got 0 equal to 0. And now check the 3, see if 3 squared minus 5 times 3 plus 6 equals to 0. Could just use my back arrow. Change the 2 to a 3. Oh, idiot. I can use my back arrow if I knew how to use it. Change that 2 to a 3. I don't know that that was any quicker, but there's my check, and it gives me 0 equal to 0. Both answers checked. I can put a big old check mark next to each. Let's do 25 together just so I don't bomb you with homework. So for 25, I'm going to sight factor. Right side is 0. My goal is to have one side 0, the other side factored. I need to factor to get started x squared minus 5x minus 6. My template tells me that I need the plus minus factors of minus 6, smaller number positive. I'm going to sight factor and not group because there's not a number in front of the squared. So for the minus 6, I'm going to go minus 1, whoops, smaller number plus bigger number minus, positive 1 and negative 6, positive 2 and negative 3. Now I'm going to add those. 1 plus negative 6 equals negative 5. 2 plus negative 3 equals negative 1. The pair I'm going to need are the 1 and the negative 6. So for 25, that starts off with x squared minus 5x minus 6 equal to 0. Has the 0 that I want, doesn't have the factoring that I want. I'm going to sight factor because there's not a number in front of the x squared. I don't need to group. I'm going to split the x squared evenly among the firsts, between the firsts, and the 1 and the 6 give me the negative 5. So in one parentheses I'll get a plus 1, the other parentheses I'll get a minus 6. Now I'm just going to write the answer down. Instead of going x plus 1 equal to 0, minus 1, and getting x equal to minus 1, I can do that in my head. Instead of going x minus 6 equal to 0, plus 6, I'll get the plus 6 by hand. And because it's an answer that I have, 25, the answer is negative 1 and 6. So that's non-calculator checking, assuming my answers are right. There won't be any cubes in this section, but there are a few squares. That's supposed to be kind. Squares with minuses are easy to factor. So for problem 26, I know one of the answers is 9, because if I plug 9 in, you square it, you get 81, and 81 minus 81 is 0. Pretty often, poor students will just do that. They'll look at the problem and they say, oh, I know the answer, and they won't do the algebra, and they won't get both answers. Usually, in the problems that need factoring, you get as many answers as the highest exponent. So I expect to get 2 answers because in 26 the highest exponent is 2. And the fundamental theorem of algebra says that you can't get more if you're solving a polynomial equation, an equation where one side is a polynomial that has an equal sign, horribly grammared there. You can only get as many solutions as the highest exponent. You can get less but not more. I'm going to factor 26. It's a square with a minus. I'm going to get my template, squares with minus factor. You get one parentheses with a plus, the other with a minus. The y squared, I'm going to split evenly between the first by dividing the exponent by 2 and getting a y to the first. The 81, I'm going to square root it and split it evenly amongst the lasts. Now I'm going to go y plus 9 equals to 0, y minus 9 equals to 0. The y plus 9 factor, I'd minus 9 from both sides and get y is negative 9. The y minus 9 factor, I'd add 9 to both sides and get y equals to positive 9. Usually, when you get opposites for answers, you write the answer with that plus or minus symbol. I'll check these just to show you. If I wanted to check the hard one, the y equal to negative 9, I'd go to the original problem, change the y to a negative 9 using a parentheses, and I'd make sure I get a true statement. I'd make sure that the quantity negative 9 squared minus 81 equals 0, and it does, so I put a big check mark for that, so I get 0 equals to 0. And then similarly, if I wanted to check the y equal to 9, I'd go 9 squared minus 81 equals to 0. Just go back and delete the negative. It equals, gives me 0 equals to 0, just fine. And I check on my answer key. For 26, I wrote y equals plus or minus 9. Let's do 29 together. In 29, I'm trying to get y equals plus or minus 4/7, assuming I don't have a math error on my key, and they're brand new, so who knows. So for 49, it's a square with a minus. I'm going to get my factoring done by creating 2 basically identical parentheses, except the signs are opposites. To fill in this before the signs, I'm going to square root the 49. I'm going to divide the exponent of the y by 2. Square root of 49 is 7. The exponent of the y becomes 1 when you divide it by 2. So before my signs, I'm going to put a couple 7y's. After my signs, I'm going to figure out what happens when you square root 16 and put that in both parentheses after my signs. So 49y squared minus 16 factors into 7y plus 4, 7y minus 4. So now I'm going to set the contents of the parentheses equal to 0. The first factor that I wrote down, I minus 4, and then divide by 7, divide by 7. The second factor of 7y minus 4, I add 4 and get 7y equal to 4, and then divide by 7, divide by 7, I get y equals positive 4/7. Since my answers are opposites, you usually write the answer with the number written once, preceded by the plus or minus sign. I just need to be able to factor, and the 3 in front of the square term means I'm going to group factor. So to get started on number 30, I need to factor 3x squared plus 5x plus 2. I multiply the 3 and 2 and get positive 6. I'm looking for the double plus factors of 6 because there aren't any negatives in this problem. The double plus factors of 6 are 1 and 6, and 2 and 3. I need the pair that add up to 5 because the middle number is 5. So the important numbers are going to be 2 and 3. The 5x in my problem I can write as 2x plus 3x. If I cared to, I could write it as 3x plus 2x. That doesn't really matter. This is all side work for factoring. So my 3x squared plus 5x plus 2, I can rewrite it as 3x squared plus 2x plus 3x plus 2. Introduce my parentheses. First term, factor out an x and be left with a 3x plus 2. Second parentheses, factor out a 1 and be left with a 3x plus 2. Then I could write the common parentheses followed by what's in front of the common parentheses. A lot of work just to get this factored, but I'm not even done, because after I have it factored, because it's equal to 0, I have to get the numerical answers. So for the factor of 3x plus 2 that gives a solution of negative 2/3, I'd have to minus 2 and divide by 3 to get the number solution that it needs. The x plus 1 factor, I know that that gives an answer of negative 1. I probably wouldn't show this work. I would just include it with my answer without showing any extra work. For 30, I think the answer is x equal negative 2/3, x equal negative 1. Again, it takes a while to check, so let me just go to number 30, negative 2/3 and negative 1. Feel good about that. Let's do 33 together. It's nothing new. It's really just checking your factoring. A lot of times, as the problems get more complicated, it's just really focusing on a basic skill. So start off for 33, I'm going to group factor it. I'm going to multiply the 3 and the negative 2 and get a negative 6. Bottom row of my template, I need the plus minus numbers that multiply to negative 6. Smaller number gets the plus. So my choices are 1 and negative 6, 2 and negative 3. The 1 plus negative 6 is negative 5. The 2 plus negative 3 is negative 1. So the pair I need is negative 3 and positive 2. The negative 5x in my problem, I'm going to rewrite as, I've circled the wrong one. I need the 1 in the negative 6. I don't know why. I've got that staring right at me, that's the negative 5, and that one is garbage. The negative 5x, I'm going to write as negative 6x plus 1x. If I'm rewriting and there's a negative and a positive, I write the negative first. So my 3x squared minus 5x minus 2, I can rewrite as 3x squared minus 6x plus 1x minus 2. Insert my parentheses, insert my parentheses. First parentheses, I factor out a 3x, and I'll be left with an x minus 2. Second parentheses, factor out a 1, and be left with an x minus 2. And then I have the common factor of x minus 2, followed by what's in front of the common factors, 3x plus 1. It just feels like I should be done. I've done so much work, but yet I'm not done, because I wrote too many problems. We'll do like 2 or 3 more. So this guy right here, now I can write x minus 2 times 3x plus 1 equals to 0. The x minus 2 is going to give an answer of 2. I don't need to do any algebra for it. The 3x plus 1 is going to give an answer of negative 1/3, but maybe I need to show the algebra for it. So I'm going to minus 1 and divide by 3, divide by 3. And get x equal negative 1/3. I can calculator check these, but I'm just going to answer sheet check these. So this was 33. 33 is supposed to be 2 and negative 1/3, and it is. Let's do 35 together just to knock out some of your homework because I think I wrote too much. It's a grouping factoring again. So for 35, off to the side I'm going to factor. I'm going to multiply the 2 and 3 and get 6. Double pluses, so I'm going to write the double plus factors of 6. 2 times 3 is 6. 1 times 6 is 6. Then I'm going to add them. 2 plus 3 is 5. 1 plus 6 is 7. I'm striving for that 5, so I'm going to use the 2 and the 3. I'm going to rewrite the 5x as 2x plus 3x. And so I'm going to take the problem 2x squared plus 5x plus 3 and write it as 2x squared plus 2x plus 3x plus 3. Introduce parentheses. First one, factor out a 2x. Second parentheses, factor out a 3. Then write the common parentheses, followed by what's in front of the common parentheses. So now I can go back and get my answers. So back in line with my problem, on the left-hand side, I put the factors of x plus 1 and 2x plus 3. The x plus 1 gives an answer of negative 1. I would just minus 1 minus 1. The 2x plus 3 gives me an answer of minus 3/2 because I need to minus 3 minus 3 and divide by 2, divide by 2. So for an answer, I'm going to do negative 1, comma, negative 3/2. In the order that you write the numbers in absolutely doesn't matter. So 35, negative 1, and negative 3/2. Perfect. Let's do 37 together and then maybe move on to the next group of problems, which is basically the same except there's a common factor you have to factor out first, and so you might get 3 solutions if you have a common factor with an x. So, need to factor x squared minus x minus 6. I can factor that by sight factoring. I'm going to look at the minus 6. My template tells me I need plus minus factors, smaller one positive. So the potential numbers that go in my parentheses are either 1 and negative 6, which add up to negative 5, or 2 and negative 3, which add up to negative 1. And there really is an implied negative 1 in front of my x. So the 2 and the negative 3 are the numbers I'm going to use for my sight factoring. I don't need to do grouping because I don't have a number in front of the x squared term. I've split the x squared evenly up into the first positions, and I'm going to put a positive 2 in one parentheses, a negative 3 in the others, and I could just write the answers down, or I can do the algebra. The algebra, I should be able to do that in my head, but if I can't, I could write the x plus 2 equal to 0, minus 2 minus 2, set the x minus 3 equal to 0, plus 3 plus 3. I can check, but boy, my videos would be hours, and I try to make them more bearable than I have been. So 37, negative 2 and 3, 37, negative 2 and 3. So we're going to move on to a part 3 and then a part 4. I still had these problems to show in this grouping for us, and oh well, I didn't get them. You should give those a try. Definitely doing all the odd problems in the section is the best thing to do. but I'm at 25 minutes for this chunk of problems. That feels good enough, and hopefully it's starting to feel repetitive. Basically, if you could factor, then what you do after factoring is the algebra. It's easy to.